Hello, everyone, and welcome to Insight Live, IT Experts Take. My name is Ken Diamond, and I am a practice development manager at Insight within our solutions organization. Today's topic for discussion, microservices. Not if, but when. For those joining us live, we would like to keep things interactive. Feel free to put questions and thoughts in the comment section below, as we will see these, these real time and be happy to answer as they come up. Joining me today to help unpack this topic, I have two industry subject matter experts, Mr. Juan Orlandini, Insight's Distinguished Engineer and Chief Architect, and a Senior Architect and Distinguished Engineer, Mr. Carm Taglienti. I will let each introduce themselves. Gentlemen, thank you for joining. Juan, I'll let you start us off.
Oh, thanks, Ken. I appreciate it. And hello, everybody. Appreciate you joining us today. And not much more to say about me other than I've been here for a long, long time, almost 25 years, and happy to share some of our industry views and the things that we've seen from our clients and our own development journeys. And Carmen?
Thanks, Juan. Thanks, Ken. And yeah, great to be here. I haven't been at Insight quite as long as Juan, about 3 years, but I've been in the industry for quite some time. And so, yeah, we'd love to share some of our perspectives with you about microservices and what we do see from our customers and clients. So I think we could probably just start digging right in if we're ready to go.
Yeah, let's dig into it. So we titled the conversation not if, but when, right? And that's actually a fairly accurate representation for most organizations that are doing their own development. It is no longer a question whether or not you should be using microservices or not be using microservices in your organization. The question has really changed into, should I be using microservices for this specific workload or application that I'm using? And what we're seeing is that like all technology gets super hyped, and everybody runs to it and wants to go do this on their own and learn those skills because those become very valuable, and accidentally creates a monster sometimes where you were perfectly okay with a monolithic or traditionally architected application. Other times, though, it's really hey, if you don't design it from the get-go to be able to take advantage of the benefits of a microservices based architecture, you end up building a huge amount of technical debt that down the road will hamper and maybe even cripple your ability to adapt and expand the workloads, right?
Yeah, so I think and it's a really good point. So I mean, sometimes when we think about this topic, we might want to say, well, what about frameworks? Maybe we're going to compare and contrast the frameworks. And I think all the frameworks that are out there, like Spring Boot, Golang, Micronaut, et cetera, there's a number of great frameworks that are out there that can help developers understand how to create these sort of best practices in terms of how they develop their code. But to your point, Juan, it's more just a matter of, do I need microservices? How am I going to implement those microservices and for what reasons? Because when you think about even legacy estates, like a lot of the work that we do with our customers is centered around application modernization. So application modernization is one of two things. Either we're taking existing applications and then moving them into a more modern environment, or we're doing a net native implementation in a new environment, whether it's a cloud or on-premise. The type of implementation that we do is really predicated on those modern frameworks. So microservices as a component of this is really important. And we can talk a little bit about as we go through this. It's like, what are the motivations for using a microservices framework or approach? And just a couple of them that I think we can talk through are, looking at it from the perspective of, am I looking to create more efficient management and maintenance of my applications? Or am I looking to create potentially a more scalable application domain that allows us to be able to do things more efficiently and effectively? And we can start getting into some of those topics as well. So Juan, I don't know if you had a different perspective on that, but that's kind of what I think are the important areas to discuss in terms of, do I do this, first of all? And then secondarily, if I'm going to do it, then what things should I keep in mind in terms of a principled approach to allowing us to be able to do it efficiently and effectively?
Actually, I think that's a great way to maybe start the next level of conversation is, what are the decision points that we end up having to walk through? And Carm, you do this on a daily basis with your team. So when you're looking at an existing application and the client comes up and says, "Hey, I need to refactor this or modernize this," what's the decision process that your team takes in order to decide, hey, let's keep it monolithic, but maybe use some more modern frameworks, or hey, let's keep the existing frameworks and just write new code that gives you new functionality? What helps you make that decision matrix?
Yeah, so it's interesting. It's a really good question, because I think while many of us are familiar with the 5 hours, 7 hours, 6 hours, however many hours you would like, rehost, or, right, exactly. But in the in the grand scheme of things, it really comes down to ROI, right? So what is the return on investment? So if I'm looking at an existing application, or I'm going to create a new one, I want to make sure that I can factor in what are the cost potentials. And I know as application developers, as systems architects, we're not really thinking too much about the cost. We're looking at it from the perspective of, wow, there's all this cool technology and I've got to do microservices because that's what everybody's doing. Kubernetes is awesome. And, there's all of these new capabilities that we have. But in the grand scheme of things, it all is sort of based off of the business. And so, not to make it completely about a business discussion, but in general, that is a big factor. So we have to think about what are some of the things that we would want to align to the business objective, which could be things that are related to, hassle-free adoption, or, ease of maintenance, or updatability, or service orientation, and scalability to be able to manage to the SLAs of the particular solution domain that I'm creating in. And then can I even find developers that understand these techniques and that are able to create these microservices architectures for the estate that I have? And then one last point on that is, if I'm using that sort of criteria as I think through microservices adoption, microservices deployment models, then at what point do I also look at each of the applications? So the threshold then becomes, if I'm modernizing a specific application or suite of applications, are they going to be around long enough that it actually helps the ROI to be positive, versus one that's like the decision doesn't make a lot of sense because there isn't really a cost benefit that works in our favor. So in the grand scheme of things, it's that's kind of how we see it, especially with customers. Clearly the technologists would think differently, but we work for organizations that need to make money, and that's kind of the reality of the situation.
An interesting thing that I don't think you touched on is part of the microservices architecture methodology is that you develop a common set of substrate microservices that are used by multiple applications, right? And one of the accidental patterns that we're seeing is that each application is built as a microservice independent of all of the other applications that you have. And there's very little commonality across the different substrate layers, right? And that's a key indicator to me, is that, hey, maybe you're not thinking about this right. It might be that you're thinking about it right, but it might be that you really need to start understanding whether or not you should start creating maybe a platform engineering team that provides some of the substrate layers. And then each application builds their own microservices that define the specific product that is being trying to build. And that is actually not something that is very common out there in the wild. We do see it. We do try to espouse it in our efforts with our clients. But when we come into an environment where there's been accidental hodgepodge of services created, it becomes a tangle and a mess and a huge amount of effort to actually undo that mess. So that's another criteria, right? Is if you're having sets of products that are going to be developed that can leverage common infrastructure components, then absolutely you should have that become microservices that have their own, essentially become a product of their own that these other products consume, and then can scale easier and accelerate your time to value to all of those offerings that you're trying to serve up.
Right. Yeah, no, it's a really good point. And the thing that we also need to keep in mind is, like, service orientation has been around for quite some time. I mean, even back when we were creating monolithic applications, we still would have, procedure calls or application calls and API models, which kind of really also relate to this concept of decoupled architecture, where we basically are saying the functions themselves are independent. We're now taking the virtualization layer and moving it along with those services. And so now the microservice model really comes down to what are those single purpose functions that can be distributed through a microservices architecture and then be scaled and deployed, and just makes our life a little bit easier, on top of a virtualization layer that isn't quite as I'll call it large as historic machine virtualization. Now we're talking about component virtualization. So it becomes a little bit easier for us to think about those microservices, to your point, that can be reused, that can be shared. And Juan, I love to talk about the distributed and federated models. It's you can then even envision across the enterprise or across your organization where services registries can be used that would allow you to be able to communicate that these services are available for use within the organization, or extended even further, marketplaces of services at some point in the future, getting ahead of ourselves a little bit. But the idea of creating these services and then offering a specific set of capability and the ability to update them independently and to ensure that they're accomplishing exactly what the expectation is for that service now becomes a very attractive mechanism and means to create application suites and I'll call it application environments, so that you don't have to be reliant on a monolithic application that you might have created. And the dependencies are so low that it allows you to be able to update and create new capabilities relatively seamlessly with minimum impact to the overall code. And then also the benefit to this is, if you think about things like continuous integration, you can make modifications at the microservices level using continuous integration techniques. And if something doesn't quite work the way you expect it to, well, roll it back. It's relatively simple to do. So there's a huge amount of power in these kinds of environments for us as we think about how we can create microservice orientation, but also then extend it even further into these decoupled architectural environments, which I think is a really, where the industry is going.
It's interesting. A lot of what you just said is exactly why people are running to microservices and have decided to deploy it. In fact, we ran a survey ahead of this session, and in that session, I think there was overall response was 87% of the audience that responded is using microservices in their organization, with 13% saying no or I don't know. So it's pervasive at this point, right? But what strikes me about that is Kelsey Hightower, who is a luminary in the SRE/DevOps world, 2 years ago, very famously wrote a blog post where he said, "Should I do a microservices?" And he said, "You probably should not." and this is one of the biggest proponents, one of the biggest names in this movement. And so I spent some time thinking about it, and what it really boils down to is it's partially what you talked about, Carm, which is, hey, does this make sense to spend money on, or will I get a return of investment on it? The other one is most applications that are working fine, leave it alone. don't break it by creating this new crazy architecture that is likely to introduce pain and suffering, right? So what's the old saying? If it's not broken, don't fix it, right? And I think that's what Kelsey was aiming towards. So that's part of the decision matrix, right? Is this thing really fundamentally broken where we need to actually do that? Or do I need to have this really rapid iterative approach to addressing new business needs and expanding the capabilities of this application? Well, if that's the case, yeah, absolutely, you should go down the path of microservices. But if you don't mess with it. It's fine, right? Think about it another way. In the mainframe days, right, we wrote applications that we didn't foresee running for 50, 60, 70 years. But there is a huge amount of our infrastructure, especially in financial services, that still consumes the services of mainframes, because that code is not broken, and actually unbreaking it or breaking it apart, it's going to be incredibly challenging. And if they can't find the ROI on it, it's very likely that there's going to be a subset of the applications that are in your environment that you're probably not going to be able to find value in doing that as well, right? It's either too hard, too big of a code base, or too much business logic is embedded in there, and it's difficult to extract it and rationalize it into a service of its own, or there's a whole bunch of ors that go into that, right? So just another way to think about it, right?
Yeah, no, it's a really good point, and the thing that comes with it is, even in the context of where you might have monolithic applications that have been, say, in service for 20 or 30 years, that doesn't make a lot of sense to move or to re-architect into a modern infrastructure. In those particular cases, there are plenty of opportunities to still create service orientation by putting service wrappers. And I know, most devs don't really like those kinds of things. At least I don't. But when you are thinking about leaving existing legacy code in place and then putting wrappers around them so that you can take advantage of the services that they do provide that are still beneficial to the organization, that allows you to be able to still create this service orientation model, and then start to use more modern techniques. And so the architectural support or architectural characteristics of this are really important as well. So that it's, if you take a microservices, or I'll call it a service-oriented mindset, then you can look for what particular techniques are most important to allow you to be able to not only prove out the ROI, but also to handle the expectations for your particular solution. So if your solution requires dynamic scalability, if your solution requires updatability, if it requires agility in terms of being able to grow the application domain fast enough to be able to address the changing needs of the application or the users, then you're starting to move more toward a microservices model where we can change services, we can tie them together through decoupled architectures in a much more efficient way, in order to allow us to be able to be that agile as in terms of our approach. And even if you look at sort of the advances that's been happening in this area, so we go from mainframes, for example, where we have monolithic style applications that we wrap with services, all the way through to many cloud providers are now offering serverless kinds of application domains, which is also a microservices style architecture, single function, decoupled implementations, where all you really have to worry about, and this is part of the speed implementation model, is all you have to worry about is your code and any libraries that might be required in order to be able to implement your particular application without having to worry about all of the idiosyncrasies of the underlying operating system or the infrastructure on which you're running. So these are also areas of consideration when you think about your application domain. But it's, if you really do need to think about this architecturally, and then what kinds of objectives are you really looking for? And if you take a principled approach, then you'll find that this decision-making process becomes a lot easier. And a lot of the topics that Juan and I are covering are really the important principles that you need to keep in mind as you think about, how am I going to address one application versus another, or each one of the existing legacy applications, in terms of, do I refresh it? Do I leave it as is? Do I just wrap it with, say, existing service wrappers so that I can access those capabilities?
Another thing that we haven't really covered, Carm, and I would love to hear your take on this, is the security aspect of this stuff. Because we really now, as we're introducing new technologies, and the footprint of an application is actually expanding, right? Because your attack surface is now each one of the microservices, not this monolith that you can wrap around the bubble. We need to start really thinking about the architectural and first principles of security, architecture and first principles of security in a different way, because you have to have API security between the different individual components, network security between the different components. So you have east-west traffic that you have to make sure that you're monitoring properly, as well as north-south traffic. And also, more than likely, especially if somebody ends up implementing your favorite subject federated environments, now you have to deal with the complexity of multiple computing environments that might be slightly dissimilar, so much so that the details of the security implementation actually become magnified and critical. So what's your take on all of that?
So it's a really good question, because as we think about sort of this, I'll call it the distributed model or decoupled model, we think about it as maybe a more complex situation. But I would argue that in a lot of ways, what's different is the same again. And this is true in computing. And so you can see, just in general, computing has gone from centralized monolithic application domains to distributed and back and forth and back and forth. And so we can see this over time. And the way that we think about securitizing these distributed components now is pretty much the same, although we do have lots of techniques that are based off of the similar principles. So like things like security service meshes, for example, allow us to be able to, when we deploy microservices, just as an example, we can use security meshes to be able to protect the microservices that we're putting into these virtualized environments. And then they are registering their network connectivity is being protected, access to their to the underlying code is being protected in the environment in which they're running. And so it's kind of the same thing that we would think about in a monolithic style environment. And I'm kind of going to diametrically opposing environments, but in general, protecting the APIs themselves, as you discussed, the connectivity. So making sure that we can have secure communications. Identity is probably still, again, the most important thing. So who's running what and for what reasons. But we're now thinking about it at maybe a finer granularity because of the microservice itself, who's authorized to run these applications. And then even if we get into a more distributed model, just as an example, network technology or network security has evolved to the point where we know how to create secure point-to-point communication models very easily through techniques that have been around for decades, and we're just doing a similar kind of thing through our communications. Now, clearly, the policy implementations, as well as the I'll call it the specific service orientations, may make it a little bit more complex to be able to define, but it also gives you a finer level of precision in terms of who has access to what within your particular service environment. Because if there are specific services that shouldn't be accessed because of high sensitivity or maybe data that they might have access to, you can do that down at the microservice level. You don't have to do it at the application level, which is how we sort of treated things back in the monolithic era. But now we're actually getting even better in terms of how we can control, but we have to make sure that we can implement our policies and our control structures efficient enough so that they can actually work at the microservices level. And there are plenty of tools, like I described, service meshes, for example, or security mesh allows us to be able to do that. Like the products like Istio allows us to be able to accomplish that effectively in a microservices implementation. Again, I'm not belittling it at all. I'm just saying it's kind of the same principles all over again. We're just applying it now to our microservices environments or our distributed environments.
So what I like about that commentary, Carm, is it's really speaking to something that we tend to forget sometimes, is that there was a lot of lessons that we've learned over the decades that we've been doing this as an industry that we tend to have to relearn when we implement stuff. And the message really should be is like, hey, there's still a need for a security and governance set of folks that actually know how to implement GRC and do those things. You're still going to need to have experts at understanding how networking really should be deployed so that it is secure, so that the layers that sit above it are actually not fragile because of the infrastructure that's below them, right? And infrastructure comes in many, many layers, right? What's infrastructure for one person is the application for the other, right? So you got to make sure that you have the expertise across the entire stack, whether it's microservices or not, to make sure that you're deploying your security models as effectively as you can. And there's a lot of lessons learned, right? There's new stuff we have to learn for sure, but there's also a lot of goodness in what we have done in the past, and some way too often we forget some of this stuff.
Right. Are you suggesting I'm old? I'm just
I'm right there with you.
just kidding. But it is important that it's in that a lot of the things that we have practiced over the years, we've learned from, especially security, for example, and security continues to evolve and change, but those basic principles are super important. It's like anything that we learn, right? You start with the basic set of principles, and then you extend them based off of your learning and based off of the way that the environment changes. And so I think what we find in this case is that we see security, just as an example, is a refinement. So we see refinement within the environment, but it also allows us to be able to know what kinds of things should we be thinking about as we look at our microservices or modern architectures and implementation strategies, because now we have this, large, I'll call it knowledge base of and experience with, implementing security within the infrastructure. And I'll even go one step further. And the thing that I find really interesting is that as we start moving more toward connected devices, we're kind of going back into this world of, the network security at the physical level, because of the fact that it's like connected devices are, guess what? They're devices. So that, we're no longer able to abstract away or virtualize the sensors and the monitors and the actuators that we might have on, or even the mobile phones for that matter, or any connected edge device. They're not virtualized at that level. Those are physical devices. So we're back into the mode of securing the physical infrastructure. So all of the best practices come into play when we think about sort of this, this innovative style, autonomous activities that occur on the edge or in the intelligent edge models that are really sort of dominating some of what we're doing related to solving customer problems.
So we're straying a little bit from the subject of the conversation. This is a good topic, though. All right.
What are you saying, Ron?
No. What I'm saying is the subject is should we microservices or not, right? And we're going down into the intelligent edge and how we connect devices and secure devices, and they're related because many of our deployments of intelligent edge solutions are microservices based, all the way down to the compute that we do at the edge, right? Mm-hmm. So you're running containerized applications that provide localized services at the far edge, right? But even within those, there's a separation of duties that we should acknowledge comes in, which actually gets exposed as the services that get consumed. And this, what I'm talking about is there's been a big push to shifting left for everything. Let's shift security left. Let's shift operations left. Let's shift everything to the left, right? But that's really almost, in my mind, not really doable, because there's domains of expertise that you just cannot shift left enough without having embedded some of the intelligence into the things that are consumed by the developer in the first place. So as an example, right, developers might be saying, hey, let's go and make sure that our application is secure. And developers are amazing and brilliant people, and they're going to do all the right things based on the best practices that they are aware of, know about. Make sure that you don't have buffer overflows, that you don't have cross-site scripting, all those input validation, all those things, right? But there's an attack surface that's below that level that they're typically not privy to or part of, and that's really a security professional's area of expertise. What should be done is the microservice that is being exposed to the developers being consumed should have the knowledge and expertise of that domain expert baked into it, so that you can shift it left, but you still don't get rid of that domain expert, right? And the reason I'm pointing that out is that if you're going to do microservices, you better make sure that you have the domain experts that can bake those services into, that expertise into the services that are being exposed to all of the upper level consumers of the microservices.
Right. Yeah, no, and I think that's true also for other characteristics of the microservices. So it's or any service, because services are reliant on a particular set of expectations. So if you're creating microservices, the decoupled nature of them means that you really want to provide keys to what is the environment within which the services need to run. For example, How do I know whether or not to scale? How do I know whether or not to provide resiliency? You can't or you don't want to codify that within the application itself. You want to make sure that the hints and the capabilities are defined by the microservices, saying that I'm, in the context in which I'm running, I'm an important function that needs to be highly available, or I need to be resilient. In order to do that, then it sort of keys into I'll call it the overall architecture to be able to support it. So like if you're using Kubernetes, for example, I can use that to orchestrate whether or not that service needs to run in multiple environments for high availability or resiliency purposes. I know whether or not to restart it. I know the key criteria with which to be able to start up a new one. I know how to migrate from version to version through CI/CD models, etc. But you don't want to codify any of that into your application environment. That would just be silly. But you do want to make sure that you understand or think about the context in which that particular microservice may run. For example, do I touch private information? Do I need to audit the fact that I'm touching, your personal information, and then I might be storing it or using it? And do I need that for the purposes of GDPR or for HIPAA or for other kinds of regulatory environments? And so those are all really important considerations, because we need to think through, as we design this, how much of this can I use frameworks for and existing patterns and blueprints to be able to help me leverage other services that others will share? And then how much of this is my service? How much is the specific service that I'm expected to carry out? As I mentioned earlier, single purpose functions that are responsible for achieving their objective. If my objective is to achieve, whatever calculation of, 1 + 1, that's my job. My job is not really to ensure the protection of the service or to ensure that it's always available. That goes to another level of services that are responsible for sort of keeping the environment sound, or the architectural support. So I think in those contexts, there's a lot of, there are frameworks out there that help to support it. There are environments that help us to be able to run our microservices most effectively. But I'm coming back to this sort of model where what we're talking about is, well, we want developers to be able to create their microservices in their own area of expertise within their own environment, without having to know all these other things, like to be a security expert, as an example. But we want to make sure that it's consistent and it works within the context of the architectural patterns for the organization. And these frameworks exist. And so these are really just making sure that the right people are doing the right things to create your application environment. And I think it can really work well for organizations that are looking to adopt these kinds of capabilities.
Hey, Carm, I'm going to jump in real quick. I want to acknowledge that Doug Fields did post a comment. He said, agreed, in general, the risk of re-architecting mature code can easily outweigh the benefits. However, there are many new applications that will benefit from a ground-up implementation of microservices. You guys care to comment?
Yeah, I'm with you there 100%. And I think it's in a lot of cases, and again, this is just my own bias. I mean, my knee jerk is like, of course I want everything to be modern architectures. But as we think about the ROI, we have to sometimes put on the business hat. But then to your point, that's exactly true. We need to make sure that we understand what the ROI is. Like, what is it going to take to get us there? And then understanding what the benefit really is of a microservices framework. Net new is easy. Well, hopefully it's easy, but I think the challenge on the net new can also be, you may have to educate an organization on the benefits of microservices frameworks, because sometimes you may not have the development resources that know how to work in those environments. You may not have support staff that know how to manage and maintain it. So there could be some education, some training that's required in order to be able to get you up to speed on these more modern approaches. So there may be challenges there too, but going in with eyes wide open, I think, is really the key here, because the benefits are clear. It's just a matter of knowing how to articulate them.
Well, and I'm in violent agreement as well. Right. So absolutely, new applications could very well be much better served through a microservices architecture, but it's not a foregone conclusion. Right. I would go under the assumption of that. Yeah, we should probably consider a new application being built on top of a microservices implementation, but keep as Carm said, keep an eye open to see, hey, am I getting into decomposition hell with limited returns on my investment, right? And if I start creating a bunch and hundreds of microservices, and really my application is never going to scale, it's only going to service a few users and all that, is that all that development effort worth it? Right? Even if you have the skills, is it worth it? Right? And if the math works out not to be, there's nothing wrong with a monolithic app. It's just another tool in the bag of tricks that we now have to address our client and our business needs.
Yep. That's great.
And do we have any more questions?
Nope.
Not add a point to that. Go, yeah.
Go ahead.
No, it's okay. Just one thing I would add to it. The other thing that I really do like about the this type of an approach is that if you can build out incrementally a set of capabilities. So you may say that, maybe you have a complex set of services that are required in order to create an application that supports your end users. You can easily break that down into different related services, and then you can create them using an iterated fashion or do an incremental development model where you're providing a core set of services first. Then you're adding on some of the more specific features that might be required for, maybe their augmented capabilities as part of your application domain. So that's also a better or more interesting approach to the way that we used to develop things, where you don't have to build all of the entire application once and all the components have to be there. Now you can take this incremental approach and do it much more efficiently, because now you're actually building out independent services and then you're tying them together as soon as they're available and ready to be deployed. So that also is pretty cool. And, of course, stubbing things out is always a good way to do it.
Well, and one thing you touched on really lightly about 10, 15 minutes ago is the recoverability, disaster recoverability, and those kinds of things. And this is something that is actually rather difficult to do in a monolithic app. That is much, much easier to bake into a microservices app, because you can distribute those services a lot easier across geographies in the cloud providers, or even data centers in the private cloud. If you have the substrate layers that actually allow you to run these containerized applications and the service meshes and connectivity and security aspects of it. In monoliths, the way we used to do it is by building HADR clusters with these highly dependent synchronous replication, all these crazy things that we had to do. And the application didn't have to worry about worrying about it being alive or not. A lot of infrastructure handled that. In microservices, the equation is flipped, where the assumption is that the infrastructure is actually not resilient and is not going to be survivable. So we build the application layers so that they can have that disaster recoverability built into it, with the assumption is that, hey, we are going to be moving things, or things are going to fail, and we're going to move around, the old pets versus cattle thing, right?
Yeah.
So that's actually a huge benefit, and if that's something that is absolutely critical, especially as you're writing a new application, by all means, go write it in the microservices. Just make sure that you have the team that knows how to implement that from the very beginning to support all of those different failure modes that you might run into in the wild.
Yeah, that's a really good point. And I also would say that resiliency changes a little bit, because in a microservices environment, I can define the core set of services that need to run in order to allow my application to even be minimally up and running or viable, versus the entire application. So I think with the application environments that you're describing, we could create environments where the entire application is either going to run on another environment, or it's running on its current environment, and there's a failover path. But in terms of microservices, I can support fault tolerance by saying, if I know I'm going to move into a downgraded version of the application because of resiliency or availability, I can pick those services that need to run and how they communicate in sort of this core capability mode. So it defines a different set of resiliency for us and fault tolerance. So it's really kind of cool because of the granularity, it gives us a lot more flexibility.
It does, but I watched a talk from one of the conferences. I forget if it's QCon or one of those, by Google SRE, and her presentation was, have you tried turning it off and on again? All right, and it's actually a great. I love that talk because it was a great litmus test. Because sometimes data centers do shut down. I don't care if they're in the public cloud or if they're in the private cloud, things shut down, and that's actually a great way to test whether or not you actually have built in and design your infrastructure and your application and all of the microservices on top of that to be resilient and not and survive these things. So that was a great talk. I should have that link, but just look Google SRE. Have you tried turning it off and on?
Right. Yeah, I think one area we didn't really focus on too much today, maybe we can pick it up at some point in the future, is monitorability and making observability within the infrastructure, because it does provide some interesting challenges, but also some interesting opportunities for us because of the way that we can monitor the application environment now is slightly different. But it's probably for another time, because I think we've covered a lot in today's talk.
Yeah, that's actually a topic we should probably explore in great depth, because it is very meaty and there's a lot. And it also changes how it gets presented depending on the consumer of the FSO data, right? The full stack observability, right? Because there's the consumer, the end user and their experience. There's the developer and their experience. And then there's the ops or infrastructure or platform engineering teams that also have to have a slightly different view, and they're all related, but the view of it might change. And man, that's a fun topic to talk about. We should absolutely do that.
Yeah, sounds good.
Well, I think with that, if there's no other questions,
I just want to thank both of you, Juan, Carm. It was a great discussion. I do appreciate the fact that you did bring up security. My background is cybersecurity, information assurance, and having that part of the discussion is always beneficial for everyone. And the fact that you guys brought it up, I really do appreciate it. I will ask that if anyone out there watching us want any more information, you could go to solutions.insight.com. And you can see all the technologies and solutions that Insight is capable of providing. And if you need to reach out and talk to any one of us, feel free to do so. I want to thank you all for joining us. Juan, Carm, thank you very much.
Our pleasure. Thank you.
Carm.
Again.